Greeting to you all. My name is A.Malik and I am from Computer Science of Engineering Department D section. I am here to display my conceptual engineering problem on the subject of database management system. Topic name is going to be shielded filex. Let's begin. Introduction part. Shielded filex is a secure file abstraction layer designed to integrate encrypted files storage with database management systems. It enables application to store sensitive files such as documents or media directly within a database while maintaining confidentiality and integrity. The system uses transparent encryption and access control to protect data at rest without requiring changes to application logic. Shielded filex supports common database backend like PostgreSQL, MySQL, and SQLite through a unified API. It is particularly useful in domains like healthcare, finance, and defense where regulatory compliance demands storage data protection. Core design principles. Security by design ensures that all file operations pass through encryption and authentication checking before reaching the database. Transparency allows developers to interact with file using familiar like input or output patterns, while shielded filex handles security in the background. Scalability is achieved by offloading large file metadata to the database while storing encrypted blob efficiently. Interoperability enables integration with existing database schemas and query engines without major refactoring. Auditability provides detailed logs of file access, modification, and deletion for compliance and forensic analysis. Shielded filex sits between the application and the database as a middleware layer intercepting file-related operations. It consists of three major main components: the encryption engine, access control manager, and metadata handler. The encryption engine uses AES-256 in GCM mode to encrypt file content and generate authentication tags. The access control manager enforces role-based permissions using policies stored in the database. The metadata handler track file names, size, timestamps, and cryptographic keys in a dedicated database table. Access control mechanism. Shielded filex implements role-based access control (RBAC), where users are assigned roles with specific file permissions. Permissions include read, write, delete, and share, each validated before any file operation proceeds. Access decisions are enforced at the middleware level, ensuring unauthorized requests are rejected early. Fine-grained policies can restrict access based on time, IP address, or user attributes for enhanced securities. All access items are logged with user ID, timestamps, and action time for audit trails. File operations and workflow. When a file is uploaded, shielded FileX encrypts it, stores the ciphertext in database, and saves metadata separately. During download, the system retrieves the encrypted blob, verifies access rights, decrypts it, and streams it to the user. File updates trigger re-encryption with a new key if the content changes, significantly preserving forward secrecy. Deletion removes both the encrypted data and associated metadata with optional security wipe for compliance. Versioning support allows keeping multiple encrypted versions of a file with independent access control. Integration with database systems. Shielded FileX uses blob, binary large objects, fields in a relational database to store encrypted file data. Metadata such as file name, size, owner, and encryption key ID are stored in structured tables for efficient querying. It leverages database transaction to ensure atomicity while updating both file content and metadata simultaneously. Triggers and stores procedures can be used to automate cleanup, backup, or the policy enforcement task. The system supports connection, pooling, and prepaid statement to maintain performance under high load. Security threats and mitigations. Data breaches are mitigated through strong encrypted and strict access control that limit exposure even if the database is compromised. Insider threats are addressed by logging all actions and requiring multi-factor authentication for administrative access. Replay attacks are prevented using unique initialization vector (IVS) for each encryption operations. SQL injections risk are reduced by using parameterized queries and input validation in the middleware layers. Denial of service attacks are guarded against while limiting and resource quota per user or role. Compliance and regulatory alignment. Shielded FileX help meet GDPR requirement by ensuring personal data in files is encrypted and accessed in logged. HIPAA compliance is supported through audit trails, access controls, and encryption of protected health information. It aligns with ISO 27001 standards by implementing information security management best practices. Data residency requirements are satisfied by allowing deployment in region-specific database instances. Regular third-party security audits validate the system's adherence to industry security benchmarks. Thank you.